we can look at similarities in the weights. We can look at differences in the weights. We can then train the model with these kinds of attacks. We can compare the changes in the weights and go, oh, what weights were changed? Once we know where the weights are changed, we know where the circuits are in the model. So now we can pinpoint exactly where it is and go, okay, let's adjust those weights and let's turn that circuit off.
Got it. Welcome to Practical AI, everyone. This is season 2. I'm with Peter Lynn. My name's Jeff Northrup. We are sponsored today by Pocket AI. Pocket AI is a tool used to perform surgery on your models to make them better. While everyone today is talking about RAG and refinement, Pocket AI allows you to edit the weights of your model directly. Peter, in early April of this year, Anthropic came out with a paper about jailbreaking and this concept of many shot versus one shot. What is Anthropic talking about there, and what's the significance of this topic?
So the topic is really about making large language models do things that the companies don't want you to do, right? So the example is when ChatGPT first came out, people did things like, hey, how do I build a bomb? How do I do X? How do I do something that's illegal? And so immediately people are like, oh, hey, this is probably a bad thing. And so all the companies started to align their models by refining it with training data sets so that when you ask the things like, hey, how do I build a bomb? It says, sorry, I can't answer that. Or for example, if you say, generate me an image of George Bush doing something illegal, it'll say, sorry, I can't do that because that's a known personality. And so as models have evolved and gotten bigger, they've got the context window, which is how much data you can give it, has grown. And the paper from Anthropic looked into, well, what happens when the context window gets bigger and bigger, does it make it easier to jailbreak? And the answer is yes, absolutely.
Okay, so jailbreaking, we've talked about jailbreaking before, and it's essentially tricking or getting the model to give you a response it's not supposed to.
Yeah.
But this concept of context window is something we haven't talked about a lot. And if I understand it, it's essentially you said it's the amount of data that you can give it to for the prompt essentially.
Yep.
But it's also kind of similarly, if you keep asking it more information or try to refine the question, no, I didn't mean George Bush Sr., I meant George Bush Jr. And as you add more into
Right.
that's all building within the context window, right? That's part of the context window, right?
Exactly. Yes. Every time you start a chat with ChatGPT, you give it a prompt, it responds, you respond to that. And so this whole entire dialogue is the context window.
Okay.
Now, obviously, if you were to take, let's say, a book by Stephen King, and we all know Stephen King can't write a novel shorter than 1,000 pages.
Right.
Right. So if you just blindly say, well, okay, let me take one of Stephen King's novels, let's say Pet Cemetery, and feed it to ChatGPT, what would it do? Well, first of all, it's too big. It's not gonna fit. And so what it'll do is it'll just arbitrarily chop off whatever it can't fit. And then it'll try to give you a summary based on what it actually could process.
So there's a upper limit on what the context window is. So that would be my first question, and that is, can you max out the context window on the first prompt?
You can, right? If you should have copy and paste, a play or a novel that's like 20 pages, yeah, you could easily exceed the context window.
So it's basically impossible then to ask a follow-up question to the first half of a Stephen King novel, if
Exactly.
that's your question. Okay.
Yeah.
Okay, but let's just assume now we're just asking it a series of questions, or we're building more context as we're trying to get the right response. How did people like what did people do in order to jailbreak then? Like what's the Anthropic paper about?
So the theft paper was very simple. They just added a whole bunch of random stuff. So for example, in the example of can I build a bomb or give me instructions for how to build a bomb, they just added a whole bunch of stuff before it, saying like, a bird is a mammal with feathers and flies. A snake is a cold-blooded animal, and they just added a whole bunch of stuff. And then the last sentence is, give me instructions for how to build a bomb. And then it does it.
Okay, wow. So it didn't have to do anything other than overload the window.
Yeah, basically.
Interesting. So in the same
Mhm.
sense, if I gave it half of a, not half, but if I filled the context window with a Stephen King novel of just text, and in the last sentence asked, how do I build a bomb? It could
Yep.
very easily do the same thing.
Oh yeah, you probably will.
All right, so is there a reason why that you can think of that the large context window results in this jailbreak gap?
Well, if we look at the architecture of how large language models work, it's kind of it, as you train a transformer, it has this thing called the memory, the attention. And the whole purpose of attention is it remembers which tokens should go together, right? So that's what learns the meaning of a word. It learns the structure of English grammar or German grammar or whatever, right? But ultimately, when you give it a large context, it's going to process all that stuff. It doesn't actually know what's important because to the language model, it's all important. And so if the last thing you have is tell me how to build a bomb, right? Like it treats the bulk of it, which is garbage, nonsense, just as important as the last sentence.
And I guess I don't understand how that somehow skirts alignment, or do we not
Well,
know?
so alignment tries to give you patterns for the kinds of things to avoid, right? But when it's a random noise, it has no pattern, and therefore you cannot align for it. It's impossible.
Hmm. Okay, so is this a problem with large language models generally, or just the large context windows inside of any model?
It's both.
Okay.
It's they're the two things are really closely tied. The first thing is we don't understand what the weights are doing. We don't know what circuits are in the language model. Therefore, we can't decipher why it's easy to fake it out by giving it a whole bunch of noise. Right. So the first step to fighting this is you have to be able to interpret and understand what the weights are doing. And today we can't. And so as a result, the way that we get around the fact that, oh, I ask it a question, it gets a wrong thing, we can prompt engineering by giving it more facts, more stuff, more hints, and it'll magically go down the right path in the model to give you the right answer. Right. So far, all the solutions have been let's just make the context bigger and let's just make the models bigger. And that'll hopefully give us the better prompt response that we want. But it doesn't solve the architectural issue of like we can't interpret what the model is doing, and therefore we can't make it more robust to these kinds of attacks.
So prompt engineering depends on larger context windows, it sounds like.
Not necessarily. There's lots of attacks that actually, if you just tailor it correctly, it'll give you the right response.
Okay. But another way to do that, to get to that, is to understand what the weights are doing. So when
Yeah.
you use Pocket AI and methods to kind of determine what exactly the weights are doing, are you can you see a future where you're able to get around this problem and essentially create a model that could not be jailbroken
Well,
using?
so right. So the ideal goal is if you can analyze the weights and short circuit it, So in other words, if I can make a model always return the desired response, then I can prove that where the circuit is in the model, and I can switch that off, right? And so really, it comes down to, can you understand the weights? Can you short circuit the weights in a repeatable way? Because if you do, then you should be able to then make the model resilient to variations of the same attack.
And you've done this in computer vision.
Well, I've done types of things like this with computer vision.
And it's one of the ways in the future that the jailbreak via context window could be solved.
Right, because ultimately, if we can discover somewhere in the language model's weights where it can figure out whether something's noise or not, right? So for example, let's say we've trained a model and I gave it 30 examples of attacks that just uses the context size. We can look at similarities in the weights. We can look at differences in the weights. We can then train the model with these kinds of attacks. We can compare the changes in the weights and go, oh, what weights were changed? Once we know where the weights are changed, we know where the circuits are in the model. So now we can pinpoint exactly where it is and go, okay, let's adjust those weights and let's turn that circuit off.
Got it. Great. Well, it sounds like there's a future out there where the jailbreaking conundrum can be at least improved. In the meantime, current approaches that the LLMs are taking, they're no closer to solving this, are they?
Well, it's an ongoing battle, and it will be until it won't be solved until you can interpret the weights.
Okay. Well said. Peter, thanks for giving us a little bit of a deep dive into context windows and this context window jailbreak technique. And you should try it, right? I mean, if you're interested, I mean, unless you don't lose your license to OpenAI, right? But you can try this at home, right? You can write a really long script of noise and then try to ask a question they don't think it'll ask or answer, and you can see for yourself. But we'll get back to you again with more topics and keep the questions coming. Thanks again. Like, reply, ask questions, and we'll try to answer them. Thanks, everybody.